Hello, everyone. As a part of PHUSE podcast series, The Undeniable Truth About 6 Skills Possessed by Statistical Programming Heads That No One is Telling You, today we're going to talk about data acumen, described as thought leadership in the clinical data arena, for which we have Sasha and Patty with us. Patty, could you introduce yourself, please?
Hi, everyone. I'm Patty Compton, and I am the head of statistical programming and analysis at Pfizer. I'm someone who has spent my whole career in the data space, starting in a rat lab looking at the effects of morphine, learning things like Minitab, SPSS, SAS, and Emacs, VI even, and then later converting to human data with a short stint looking at election data and polling data, and landing in the last 20 years, the clinical trial data space. It's interesting for me, we've been using SAS this whole time, and we still use it, but we continue, I think, with respect to data acumen, looking for new approaches and ways to understand our data.
Thank you. Sasha, could you introduce yourself, please?
Yeah, thanks, Gayatri. My name is Sasha Avela. I'm the global head of statistical programming and analysis at Bayer. So I've been here since about 6 years. Prior to that, I worked in other pharma companies and also CROs. And I work with medical data, also mainly using SAS as Patty, since more than 25 years. I'm an educated mathematician, and while studying in the University of Düsseldorf, I also worked at the Institute of Medical Statistics. And there I created box plots for dental implants. And that was where I learned in the hard way how important the understanding of your data domain is, because initially I did it totally wrong. So I'm really glad that we will talk about this important topic today, because it's a topic which is very dear to my heart.
Thank you. So what is the definition of data acumen in the programming world, Patty?
I think data acumen refers to a programmer's ability to understand the data, for the programmer to help support and make good judgments and good decisions with the data, to use data tools responsibly and effectively, so that when we present an analysis, we give confidence to our teams and other stakeholders that the analysis was done appropriately, the conclusions are accurate, and it's well documented. I think a programmer has to have that ability to manage data as an asset, to know that condition of the data, to know what conditions can be drawn and how to share them.
And you have anything to add, Sasha?
So really nothing much to add here. I think Patty described it really well and was spot on. What I think is also of critical importance is to understand the purpose of the data. And so we need to understand the purpose of the data we are working with, because it makes a huge difference if we use the data for regulatory purposes to report a clinical study, or if we use the data for an ad hoc or exploratory analysis. So for the first case, we have to adhere to strict data standards. So beyond the understanding of the data, we also need to understand the metadata concepts and things like that. And just don't get me started to talk about real-world evidence data. That comes with its own limitations. Yeah.
So are there any limitations with technology tools or usage of data itself now that you started talking?
Yes, absolutely. I mean, there are big limitations. So I think our statistical programming organizations in the recent years, they have turned somehow into data hubs. So today we are somehow the gatekeepers of our data assets, as Patty called it. So especially when the data is used for submission purposes. I mean, we are talking about highly sensitive patient data here. And this comes with a lot of limitations, especially when you think about these data privacy rules. I mean, you don't want that everyone can access your data. And I mentioned the real-world evidence databases earlier. So these also come with a lot of limitations. You need to license the data, and sometimes it must not leave the country. And so there is really a lot to learn here. Yeah?
And Patty, you have anything to add?
I think Sasha covered it. I'm more interested, he has a large role in PHUSE in how this group can help share these limitations or potential advantages
That's a good question. I mean, speaking about learning, right? Well, at PHUSE, I mean, you mentioned that I have a role there. I'm the educations director, and we try help educating our clinical data scientists across the globe. What we are focused on in our education efforts is also, of course, on the technical level, but it's also the understanding of the therapeutic areas we are working on. So we need to understand the science behind the data as well. Here is where we hope at PHUSE to help.
Talking about science, so how fast can science go, Sasha?
That's a great question, Gayatri. I mean, right now we are living in a time of a global pandemic. So what does it mean for a statistical programmer to work on COVID-19 vaccines, for example? And so I think there are a lot of companies which were and which still are under huge pressure to be quicker on science. So I mean, the entire world is currently looking at us to see how fast science can go. But with working at Pfizer, I think Patty can tell you much more about that. She has way more experience here with working under this huge pressure right now. Yeah,
I can agree. Patty, you wanted to share your experience?
Yeah, I think it's a good question to ask. And I think with living through a pandemic as we are now, there are a few things programmers should think about in answering the question, how fast can science go? One, better engagement with health authorities, almost real-time engagement will help us to go faster. I can tell you for our COVID endpoint, it was not just one field on a CRF. As you might imagine, there's inclusion, exclusion criteria that you have to be able to explain to justify what is an actual COVID case. Did they take it within the right framework as specified in the protocol? Were there any major protocol deviations? All of that helps to clarify a true endpoint, and deriving that isn't always so easy and needs engagement with the health authorities so they can understand how it was collected and reported. I think just as Sasha mentioned, the real world evidence are evolving sources of data, whether it's patient registries, wearables, placebo-controlled data, other sorts of data. We look to add that to inform what is going on, particularly in the COVID space. There are a lot more questions that have come up in terms of variants and everything else, quickly looking for these answers and how to contextualize. And the last space is data sharing. For me, we all have guidelines of how we share our basic results. We have evolved new platforms with Transcelerate, Vivily, IMI sponsors many, and recently for COVID, ICODA came out on how we might share the data with collaborators to expedite the science. And I think that's going to be part of the secret ingredient in pushing science faster, that we know how to share this data. And I think programmers play a role, whether we share it with patients, investigators, collaborators, health authorities, journalists, watchdogs, and even competitors. I think adding this to our toolbox of data acumen is going to make programming a very interesting field and a solid contributor into the speed of science going forward there. And I think it's a glorious time to be a programmer.
We appreciate you for sharing the real-time experience today with us. We hope you enjoyed today's episode and subscribe for future episodes. We would love to hear from you. Please provide your feedback and a review for others to know what to expect. Thank you for your time.